Now, one thing we must keep in mind is when we're doing these problems, meeting and dividing, I will consider approaching, and when we get to adding, subtracting, it's going to be meeting / exceeding. So let's look at some basic ideas, right? Here we have 4 times 2. Well, 4 times 2 we know is 8. But what if we wrote it as a fraction, right? Well, we know 4 divided by 1 is just 4, and 2 divided by 1 is just 2. But how would we proceed? Well, the only logical way is to multiply across. 4 times 2 is 8, divided by, well, 1 times 1, which is 1, and therefore our answer is just 8. So you could see that when we're multiplying, the first thing we want to do is just multiply across, right? Now over here, well, 3 times 4 is 12, and 2 times 3 is 6, right? And 12 divided by 6 is 2. Right, and then that becomes my simplified answer, right? And so you could see with these problems, you just multiply across. So now let's go and look at an example like this here, right? So the first thing we always want to do before anything is we want to convert all these problems into, well, yes, we want to convert them into factored form. Everything should be perfectly in factored form before we proceed. And the reason why is we might be able to cancel things out, right? And so I'll look at this first expression here. And we have, let me change the colors. I want to use something that's more cute. All right, there we go. Now, I want to, there's this 4x plus 20, right? And it's hard for me to see how it really looks like for me to potentially cancel anything out. So before I do that, I want to maybe try to pull that 4 out. And what I mean is I want to undo the distributive property or undo the idea of foiling, right? So we're going to think about it like this. I'm going to pull the 4 out. And essentially what I'm doing is I'm dividing the 4 out. I'm taking the 4 out, all right? And so 4 divided by 4 is just 1. So I'm going to get x, okay, plus, and 20 divided by 4 is just 5. Okay. Now you could see that if I distribute it back in, I actually get the bottom term. 4 times x is definitely going to give me 4x. And 4 times 5 is definitely going to give me the 20 here. So all I did was pull out the 5. All right, now we have this. And if you want to, you're welcome to put the parentheses around your factors. Now we have over here x plus 5 divided by, and we have this x squared minus 9. All right, so maybe one of the first things I want to do is I'm going to turn that into factored form. And it might be helpful to put a placeholder in, 0x minus 9. All right, and the first thing I'll maybe want to do is write all the factors of 9. 1, 9, 1, 3, and 3, right? And we know 1 times 9 is going to give me 9. All right, well, one of them will have to be negative, but can we add or subtract 1 and 9 in any way to get 0? Well, we can, right? 1 minus 9, 1 plus 9, nothing gets close to 0. But if you look over here, I'm liking this opportunity right here. All right, 3 minus 3. I think is going to work out perfectly, right? 3 minus 3 gives me 0, and 3 times negative 3 gives me negative 9. So I'll go ahead and write the bottom as x plus 3 and x minus 3. Okay. Now that I have this there, now if you want to, we could essentially start canceling things out because they're on opposite ends, right? We have things on the numerator and denominator that we can start canceling out. That's going to simplify to 1. But before I do that, if it's helpful for you to see how this all works out, because we just multiply across, right? We're multiplying across. I'm just going to put everything together. X minus 3, x plus 5, all divided by 4, x plus 5, x plus 3, and x minus 3. All right, so you could see that I put everything kind of, all the things on the numerator together and all the things on the bottom, the denominator together. They're all just multiplying, so I just have it all multiplied. Now you can see, well, x plus 5 are going to cancel. They're the same factors, top or bottom. X minus 3 and x minus 3 are going to cancel. Therefore, I'm just going to get 1 divided by, right? Because everything, there's nothing left in the numerator except once we divide those out. And we're going to have 4 times x plus 3. Last but not least, we can distribute the 4 across, and we're going to get 1 over 4x plus 12. And this will be my final answer. All right, and you can see how we went from something that looked pretty ridiculous, turn it into factored form, and we get something that looks very manageable. So let's go ahead and try another example. Let's see here. Let's try 5x plus 5, x minus 2, x squared minus 4x plus 4, all divided by x squared minus 1. Okay, so again, we can multiply across. Now, you may feel very inclined to start multiplying, but again, remember, step number 1 is we always want to convert this into factored form so that we can start to cancel things out. So if we focus, let's just focus on this, right? We see this 5x plus 5. Like before, I want to pull out the 5. Anytime you see a number in front of x, you generally want to pull that out. Right? And then you could basically do that by doing 5 divided by 5 and 5 divided by 5, and that just gives me 1 for each term. So we're going to get x plus 1. Again, you can verify it. 5 times x gives me 5x. And 5 times 1 definitely is going to give me 5, right? All divided by x minus 2. And now we have this top portion. So again, I want to factor the top. So we have x squared minus 4x plus 4 up here. I'm going to write all the factors of 4. 1, 4, 2, 2. Well, I recognize, right, 1 and 4, we can't add or subtract these to get negative 4, so that's not going to work. Well, I could do this, right, use 2 and 2 to give me 4, but I need a negative 4, so I can make both of these negative, and that's going to give me the negative 4, and negative 2 times negative 2 gives me the positive 4 right there. So I like where that went, so let's go ahead and write that up here. X minus 2 and x minus 2 on the top. Again, you can verify it. Negative 2 plus negative 2 gives me negative 4. Negative 2 times negative 2 gives me positive 4. Okay, this is all divided by x squared minus 1. Again, if it's helpful, I'll write it as x squared plus 0x minus 1. And if I write all the factors of 1, it's just 1, 1. So 1 minus 1 is going to give me the 0. And so I'll go ahead and write it over here as x plus 1, x minus 1. Okay. Again, if it's helpful, I'll just rewrite everything so that all the numerator terms are multiplying nice and conveniently on top. All divided by minus 2, we have x plus 1 and x minus 1. Okay, well, now we could see that this x minus 2 is going to cancel out. This x plus 1 and x plus 1 is going to cancel out. And we're going to be left with 5 x minus 2 all divided by x minus 1. Okay, now we could just distribute the 5 across, and we're going to get 5x minus 10 all divided by x minus 1. And this is my final answer. Now, some of us might be tempted to try to cancel these out right here, right? And that's not possible. We can only cancel out factors like we saw here. We can only cancel out when they're the exact same identical factors. If they're not, we can't cancel them out, all right? My last example for you for today is this example right here. Let's say we have x plus 2 all divided by 4 times x plus 3 all divided by x plus 5. Okay. Now if we look here, again, maybe first thing I'll do is just put parentheses around the factors, right? Sometimes the problem doesn't have the parentheses, and you can put it. Now, since we're just multiplying across, this is multiplication, we're multiplying across, I'll just put it as x plus 2 and x plus 3. They're all multiplying, all divided by 4 times x plus 5. All right? Okay. Okay, well now you could see, does any factors cancel out? Well, no, we have x plus 2, x plus 3 on the top, and x plus 5 on the bottom. There's nothing that cancels out. So you can see that a problem like this is already into factored form. So all we have to do, I guess, is just have to multiply across and distribute. So on the top portion here, we're going to get x times x, which is x squared, x times 3, which is plus 3x, 2 times x, which is plus 2x, and 2 times 3, which is plus 6. All divided by, well, 4 times x is 4x, and 4 times 5 is 20. And we're going to get x squared plus 5x plus 6, all divided by 4x plus 20. And you can see a problem like this. This is my final simplified answer. There's nothing I could do, because if I was able to have canceled something out, I would have been able to cancel it out right away originally when it was in factored form, right? So that's a big thing to remember, is that in some scenarios, things are not going to cancel out. And if that's the case, you just have to multiply across and complete the problem. All right. Hopefully this helps. Thank you.